Okay, welcome to another session of the Portland Python Pirates. My name is Chris Thompson. This group has been around for, 5 years or something like that at this point, and happy to have seen it grow. Just heard that some people have recommended it in other groups. That's great. That's awesome to hear. Glad we're still providing value. So our website, which has not been updated in some time, but has some awesome resources nonetheless, is Portland Python Pirates, or excuse me, pythonpirates.org. Feel free to visit that. Drop us a note or something if you have any questions or comments or suggestions or anything like that. There's a space there for that. And someday we'll get around to updating it, especially now that we're doing a lot of Gen AI stuff. I suppose this is as good a time as any to start updating the resources section with a lot of that stuff. So hopefully we can get on that soon. If you're interested in helping, that's great too. Feel free to send us your favorite resources, and maybe we'll put them on the page. And we may even go back. We used to be hosted on GitHub, actually. Now we're hosted on Squarespace. So we might go back to GitHub. And if we do that, then you could just do pull requests, which was awesome, but it was rare that anybody did it. Now that we have more members, maybe that's a good system to go back to. We'll see. Anyway, totally off topic. I'm really good at that. Let's move on. So I suppose I'm the captain of this group. I started it back in a coffee shop with like a dozen people, members back in like I said, 2018, and known Brian forever. Brian and I came up through tech together in the Portland scene since 2016, 2017, something like 7 years now. We've known each other and both supported each other through our journeys into tech, and now are both wildly successful. No, we're doing all right. Yeah, we made it. So he'll be presenting the second half of the actual tutorial tonight, and I'll be conducting the first half. Our group is inclusive, so everybody, all backgrounds, all walks of life are welcome. We are Python focused. We dip into other languages every once in a while if needed, but for the most part, we stick to Python, one language. We do progressive learning, so we try to start, if we do any series or anything, so right now we're kind of doing Gen AI. Our last talk was on prompt engineering, just real light introduction to that. We're starting to dive into more application of Gen AI, and we look forward to doing more of that. It was well received, so hopefully we can get into some more complex use cases, maybe cloud-based or something to that effect. As we move forward, but we try to do progressive learning where we start off easy and move forward from there. So, but also try to cater to everyone, right? From beginner to expert. So if you feel lost, or if you have any questions, or if you're an expert and you have something to add, feel free to jump in. We're also collaborative, so that's the jump in part. If you have any questions or comments during the presentation, it's great if you drop those in the chat and or raise your hand. Use the little raise your hand button, and we can get you on that way. Just so we're not like chaotic and all over the place with the presentation and answering questions and all of that stuff. But we'll try to stop for questions anyway, just to make sure that people are following along. All right, so our agenda tonight will be kind of a recap that we already did last time, but I thought it'd be good to just go through it again, just to make sure everybody's kind of on the same page as far as what we're going to be talking about. I'm not sure we're doing prompting techniques. That might be a typo for my copy and paste laziness, but we are doing Intro to LLMs and Retrieval Augmented Generation, and then we'll have a QA. At the end. Like I said, we'll stop for questions all the way through, but we can have a discussion, or we can tangent anytime we want, right? Off of anyone's questions, but we'll try to leave room at the end, 5 or 10 minutes for questions at the end. I am a meme of theme, and I always try to find funny memes, and I try not to reuse memes in presentations. This one killed me, so I had to bring it in. Okay, so some resources that I wanted to bring up. I'll drop these into chat right now. one is, the first one is Pinecone. So Pinecone, you may have heard if you've read anything about generative AI, Pinecone is a vector database offering kind of a managed solution where you just give them your data and they kind of handle the replication, scaling, sharding, like all of that good stuff. And so, but they also have a bunch of really, really awesome resources, including ebooks and tutorials, not just related to Pinecone, but related to generative AI in general. So if you're curious about any topics from prompt engineering to vector databases, and including what we're going to talk about tonight, which is retrieval augmented generation, AKA chat with your data, definitely check that link out. That's a really good resource that I refer to pretty often. Oops, I'm trying to copy from the video, not from my actual slide. Here we go. All right, so the second one is Langchain. Of course, that's what we're going to be using tonight. Not of course, but that's the library we're going to be using tonight to demo what this would look like in code. And so you may have heard of Langchain, and we'll explain more of what that is, and you'll get a better feel for it during the demonstration. I won't go into that. I'll let Brian handle kind of what that is and what that looks like. But their documentation is really great. Definitely check that out. I always encourage people to go to the documentation before they go to Medium or even ChatGPT or anything like that. Definitely check out their documentation on getting started. They have a bunch of great tutorials and information, and even links to like the relevant papers that are associated with some of the things they've implemented. So it's super, super useful. Also a resource I use quite often. The third one is the Huggingface NLP course. I completed this, I don't know, fairly recently, just to make sure that I'm up to speed on everything. I've been working in NLP for a number of years, but you can never hurts to revisit the basics. So this goes through everything transformers related, teaches you, encoder decoder models and all the different ways you can use those models to for applying machine learning to unstructured text data. So if you're interested in knowing the nitty gritty and also learning what Huggingface is and how you can use it, use these open source models. So you may have heard of, something, LLaMa2 and things like that, and T4 and all the cool models that are coming out, Falcon. You can actually test them out on Huggingface, and it's open source and free to use. So really great way to become familiar with models, test out the latest and greatest, and also integrate them with your applications. So do that as well. Yeah. So, all right, let's jump into it. Yeah. What are LLMs? Right? You've heard of them. LLM stands for large language. Yeah, okay, I just want to stop real quick. There are some other courses on deeplearning.ai that are free right now that are related to Langchain and chat with your data. And I think the newest one is weights and biases, which has a lot to do with ML ops and, related to like LLMs and stuff like that. So if that interests you and you want to dive deeper, not just into NLP, but in general, the application of all of this, building applications and all of that, definitely check that out too. That was a great one. There's another one on, sorry, I'm like rambling. I didn't put these on here because there's just so many like resources. I just threw a few, but there's also an edX course that came out from Databricks that is a two-parter with LLMs and they dive really deep. So if you want to go super deep, and it also explains Huggingface and Langchain and like those types of things, that's another resource for you. What I kind of like about the edX one, and I probably should have included it here because I'm taking it and they just released the second course, you get a certificate. Certificates don't necessarily mean anything, and unless they're from a reputable source. In this case, it's Databricks. Databricks carries weight, and they're really good. Their courses are really good. Their materials really good. They have other certifications. So if you're interested in like beefing up your resume for generative AI, that edX professional certificate, Brian just dropped the link. Thank you, Brian. Is another one that I would suggest taking if you actually want to have proof that you can do things, or at least proof that you might know how to do things. Of course, they'll probably ask you questions, so be sure you pay attention and actually know what you're talking about. Oh, man. But there's about 5 courses on deep learning AI, I think, right now that are all very awesome. I've taken those. Anyway, gosh, there's an unlimited amount of resources I can define. But let's get into what are LLMs. LLMs, large language models. So large language models, move this slide. Large language models, they're AI systems that predict the likelihood of a sequence of words. They came out in the late 2010s. So like the Transformer came out, and then BERT, Google's BERT model, right, came out, and it took the world by storm. It was a brand new architecture, this encoder model, and it was amazing. It was doing all these tasks that before had been done with like LSTMs and things like that. And some more rudimentary styles, but lots of pre-training needed, or pre-processing needed, and really they were a bit naive, right? So Google Translate's been around forever, but once Google's BERT came out, and then some of the encoder decoder models and things like that really took off, and it all kind of started with the BERT model. There's the paper on that. The classic one is attention is all you need. And so this attention mechanism is the thing that made it so good. Now they're trained on a vast amount of data. So GPT-3 was trained on an estimated 45 terabytes of data, which is an incredible amount. Well, at the time it was an incredible amount. Now GPT-4 more, but is also not a single model, but we won't get into that right now. They're generative models. And what this means is that they're not just predicting things from past data, right? Like classification or predicting a number. They're generating like brand new, and this has some nuances, but for now, for all intents and purposes, they're generating new content, right? So they can create content knowing past or other content. So they're trained on like all of Wikipedia and all of the internet scraped, right? And so they're able to have generate human-like content, right? And there's also image models that can do a lot of the same, but for images, and they can be used for, but these NLP models specifically can be used for translation, summarization, and other tasks, classification, and all kinds of stuff. And so I found this really interesting graphic, and you can see it here. It's a blog post called "The Future of Large Language Models: Strategy, Opportunities, and Challenges" website here. And it talks about NLP Moore's Law. And so Moore's Law stated that I believe it's the number of transistors has doubled year over year, right? And was exponentially growing. We're starting to see a ceiling to that, which is kind of interesting. But nevertheless, the idea is that computing power has basically, been increasing exponentially over time. So they're proposing that the same thing is true in terms of the model size. So the model size seems to be increasing exponentially as well. Since the first one, the Transformer, and here we are, GPT and the BERT model, and then so on and so forth. And NVIDIA Megatron's a big one, and then here you see, of course, GPT-3. So kind of an interesting trend that we're seeing. We'll see if it holds. We'll see how long that lasts, because there is some controversy about whether model size, while model size, we've seen performance increases in model size, it can also hurt the model. And many of the neurons, if you understand neural networks, many of the neurons within some of these models are actually dead. They find that they're not actually contributing to the end result. So starting to be thought that model size is not necessarily where we want to go. And so there's a lot of companies working on optimization techniques to models while maintaining performance. But for now, this is just an interesting trend that we're seeing. Take from it what you will and take it with a grain of salt. Okay, any questions on that before we move on to RAG?
Keep going.
Nice. Okay. So we're going to talk about something specific. So last time we talked about prompt engineering, and prompt engineering is simply prompting these models, which are essentially black boxes. You don't really know why they're doing what they're doing. That is also an area of study. So if you're interested, definitely check that out. But besides just chatting with a model, right? Like creating a chat bot, what else can we do? Like, what applications does this have in the real world, right? Businesses want to know how to utilize these things, and a pre-trained model that's trained on the entire internet is cool, but how do I use that to gain insights into my data? Because my data is private. The model is not trained with that. It doesn't have knowledge of my data. So one technique for doing that, besides fine-tuning your own model, which is a perfectly reasonable thing to do if you have enough data, time, labels, and so on and so forth. But instead of fine-tuning a model, right, on your data, and by fine-tuning, I just mean retraining a model that is already trained, just fine-tuning it to your data, we can use something called Retrieval Augmented Generation. Retrieval Augmented Generation, or RAG, is this idea that we can take our data and within the prompt, and a prompt being input into a LLM, we can insert context. So if I ask the model without giving it context, what was my revenue last year? The model understands generally what that means, but it doesn't it doesn't have that information. It wasn't trained on that information. So it will likely not actually, it won't say, I don't know. It'll probably say something, but it will be what we call a hallucination, meaning it's just talking out of its butt, right? Like it doesn't actually, it's not true. And you know that because it doesn't have access necessarily to your data. Although revenue, you could argue, is potentially public if you have a public company. But maybe we'll talk about internal, we'll just say some private internal company data, right? So what we can do is actually take the context, so take our data, and we can feed it into the prompt when we ask the model a question. So instead of just saying, what was our revenue last year, you can say, what was our revenue last year? Take a look at the context below, and we can take data from some database, maybe a SQL database, or we have the information chunked out from documents. And by chunked, I mean split into relevant sections for context, and then inserted into your prompt, which is just a string of text that we're feeding to the model. And then it has the relevant context to actually answer our question, assuming that in that context you've provided the revenue, in this case the revenue data that it needs to answer the question. But we found that when you do give it the proper context, that these models are in fact able to understand the semantic meaning behind what you're asking and able to use that context to answer the question. So that way we don't have to waste time, or I should say spend time, getting a data set together, labeling that data set, which means giving it answers, because the model needs to know what's correct and what's not correct. We can just tell it what we're looking for by just telling it, hey, here's some revenue from last year, and then letting it answer the question that way, right? And so this way we get more factual and data-driven responses, and they're more useful, right? And they do need to be based on existing data or documents, and we can feed that in through this process. So that's all very abstract. So let's look at what that actually means really quick, and then we'll move on to an actual demonstration, which I think will make it much more concrete than me just rambling on about stuff. But So step one, like I said, we have a prompt, a query, right? And so the prompt might be, you're a bot that is, a financial expert, and people are going to ask you questions, and you should respond with only factual information, something to that effect, to let the model know what it's supposed to be doing. Then you have the user query, which is the actual question. And by the way, this is just a string. So think of this as nothing but a string. But the query from the user is then, what was our revenue last year? That feeds into here. This is a laptop. It's not a laptop. Or they put it into the laptop, I guess. That's kind of a funny thing. I didn't really notice that when we originally got this graphic. Like, obviously, you're coming from a computer. But they put it into their computer. And that query, so instead of going straight to the large language model, the LLM, which exists over here, often is OpenAI, and that's the symbol. The first step we do is actually query a knowledge base. And in our knowledge base, we have knowledge sources. So we might have unstructured data in PDF documents. We could have structured data living in SQL databases. And there's different tools on getting that information out, right? Different cloud services that provide us ways to extract that knowledge from these different sources. But what we want to do is get that knowledge out of there. We want to find the relevant, and takes a lot of time. Brian's going to go a little bit more into that later, but this is one of the parts that takes the most time. Just like in machine learning, gathering your data sets, and figuring out how to pre-process them in the right way and create features for your machine learning model. That's the same with this. It's really, really crucial that you get this step right in order for this process to work. And it's often very, very difficult. This is probably one of the most time-consuming parts of the whole thing. But once you have it, you're querying this knowledge source. You bring that information back, and you combine it, concatenate it, insert it into this original string that we had. Then you send all of that. You see in step 4, we have the prompt, which I explained, the query from the user, enhanced context, which we send to the model. The model then looks at this. It says, okay, I'm a financial expert. Got it. What's the query? The user's asking me about financial information. Got it. And then it says, okay, I have some context here. Let me take a peek at that. Oh, I see the revenue here. Then it sends its response, and that response is what the user sees. So you see that we actually are able to get at private data within a company, and there are private endpoints. This could be a self-hosted model from Huggingface, or it could be a private endpoint from OpenAI on something like Azure, or it could be Bard on Google Cloud. And your data actually is not used, at least in Azure OpenAI, to retrain the model. So when you're scared, a lot of companies do not want their private data, for good reason, being used to retrain a public model, because it's been shown you can actually, by red teaming it, they found that they can actually get like data from the training set out of the model. So it's good that we're not using this data to retrain, but nevertheless, you can still insert that on a private instance of the model and get the result back for your users. So this can be used internally within the company. Let me see. I see a...
the question from Nir is, how large can this, basically how big of context can you include in there, like in the prompt that you send to the model? And I mean, so ChatGPT-4 takes what, 32,000 tokens or something like that?
No, I'm actually asking, how large can the retrieved data from the knowledge source be that the LLM can, handle both that and the prompt? Like if I intend all of the database, obviously it's not going to work. So how specific does it need to be?
It needs to be specific. So this is where the kind of art form comes in, right? It needs to be specific enough that you capture the relevant context, but it needs to be big enough so that that context is actually contained within there. And I don't know if I said that right. Okay, so it needs to be small enough so you're not overblowing the token limit, tokens being what you're inserting into this large language model, but also large enough to capture the relevant context for the question you're looking to ask. Right, so in my case right now, I'm working with something called cognitive search on Microsoft Azure. And they have a way for you, and this is where vector databases come in. And we'll talk more about vector databases in a moment. But these vector similarity searches are what allow you to find the relevant data that you need using a mathematical representation. So vectors in a certain latent space, right? Matching those up and pulling data that's related to your query. So you, and foreshadowing here, Brian, I'm going to pass it off to you because this is a great segue, but I'll just say that you would embed this query into a vector, and then you do a similarity search across these different knowledge sources, say in a vector database. This is a vector database example, but you would do it across these vectors to find relevant information that's related to the query that you're asking. And so the hope is that if you did this part right, you can only retrieve very little information, but it matches very closely or contains the answer that you're looking for. But there's no hard and fast rule, right? But your intuition is correct, where you want it to be small enough where you don't blow the token count, but you can't feed it everything. One, because you blow the token count, but two, the model will get confused and not understand what it's meant to do anymore, right? So the more text you throw at it, the less it understands what the point of your question or your query is in the first place. So this involves a lot of testing and a lot of staring at text to get it right.
So Chris, Loretta asked a really good question, which we won't cover later, and that is Huggingface models are a bit big to host on like a laptop, but if you need to move to the cloud, which cloud providers would you recommend from a data security standpoint to host, either like use their own private models or to host a model on its own, on your own?
That's a really good question. There's not a specific, I mean, I'm working in Azure right now. That seems to be working well, but I mean, clouds are moving very quickly to integrate with Huggingface. I know Databricks has a really close relationship with Huggingface, and Databricks can live on any cloud. What I would say is that if you're at a company, whatever cloud provider you're using, probably just go with that, because the models are open source. If worse comes to worse and they don't have direct integration with Huggingface, you can at least host they at least have some mechanism for hosting the model through their respective machine learning platforms that they provide, or machine learning services that they provide on their cloud platform. So I know that's not a great answer and you want a better answer, but the answer is basically go with what you know. Here you see Amazon SageMaker, that's an option. Something like Machine Learning Studio on Azure and Vertex AI on Google. All three provide ways of hosting open source or custom models. So choose one. That's my answer to that, I suppose. Yeah. Cool.
Okay.
Any other questions, or can we jump into demo time?
Let's go to demo time.
Demo time. Okay, cool. Wait. I have something for that. Show me the demo. All right. I told you I'm a meme guy. All right. Brian, I'm going to stop sharing and I'll let you share your screen if that's okay.
Yeah. Okay, hold on. Like double sharing. Okay. Can you see a collaboratory notebook?
Can you make it slightly bigger?
Man. How's that?
That's good, thank you.
Okay, perfect. Okay, there are several questions that are going on right now, by the way, Chris. Okay, but maybe maybe we'll pause for now, or pause on the questions for now.
Yeah.
So, all right. So what I hope to accomplish in this demo is, I mean, this demo is a representation of learning that I'm doing because I'm trying to get up to speed on how we can potentially use LLMs to implement what Chris just talked about, to be able to take work off of our backs. Because, so I lead one of our data engineering teams here at a healthcare tech company based in Boston, but I work from home in Portland. And we get questions all the time from internal stakeholders that are asking us questions that sometimes we do or don't know the answer to, like, hey, how many clients have this product turned on? When did they go live with this product? How often is it being used right now? Like lots of questions that either some of them we already have a really good data model for, maybe we have a dashboard for, and they just didn't know about it. Other ones, they're asking questions that I know we have the data for, but currently all of our data products aren't quite pinpointed towards answering that specific questions. So then we go and we dive into the data, we provide a question, we provide an answer for them, and we spend at least one developer a couple days overall in developer time a week in order to be able to provide this level of service to the rest of the internal organization. It's valuable. We're the data stewards. We're the type of people that they need to come to for questions. But when I started learning about the capacities of LLMs and retrieval augmented generation, I thought, hey, it would be great to do at least a little bit of a proof of concept for being able to take some of this question answering workload off of our backs and put it onto some type of chatbot that can be connected to our data on the back end. So this is just a very preliminary example, and it's all going to be using dummy data that I created for better or worse, because all of our data is all PHI since we're a healthcare tech company. But here's what I want to be able to do today. So I will eventually make this notebook accessible. It's not right now, so just give me a few days to be able to make that happen. But what we're going to do is we're going to implement retrieval augmented generation by first looking at some PDF data. So let's suppose that you have a use case where you just have a bunch of PDFs. They're sitting somewhere and you wish that you could automatically parse information from them and ask it questions. So we're going to grab PDF data from a directory and we're going to store it as Langchain Documents. We'll talk a little bit more about Langchain here in a second. We're going to clean up that text. We're going to put it into a vector database. Chris just talked a little bit about those. And with this vector database, we're then going to be able to ask specific questions and retrieve documents from this vector database that hopefully will be very similar and relevant to the type of question that we're asking it. And the types of documents or data entries that we'll retrieve from this database will completely depend on the type of question that we are asking it. That's the idea. And then we're going to tie this vector database, the types of questions that we're asking, together in a retrieval QA chain, which is a Langchain term, to be able to build that prompt plus query plus enhanced context prompt that Chris just mentioned earlier, to send all of that information to an OpenAI endpoint and get a response that is directly using the source context that we provided. So a lot to do here and not a whole lot of time. But first, let's talk about some PDFs. So like I said, at work, a typical question that might come in is, hey, what date did we sign with a certain customer? Are they live with the product yet? What specific things did they purchase? So I went ahead and I looked online at some statement of work templates or SOWs. And these are the types of things that our company would get. Obviously, this is a very simple, dumbed down type of version. But I created 4 test SOWs that all just say, and I had I'm really bad at coming up with fake dummy names. So I had ChatGPT help me out here. So since I'm in the healthcare tech space, ChatGPT recommended that my company, pretend company name is DocFinder Hub Pro. That's a lot of Hub Pro Finder things. And that, so now we are supposedly in some type of agreement between some fake company, Sunrise Medical Group. That'd be a bummer if they actually existed, and I'm pilfering their name. And apparently we sold the client on this product called Metabot Pro, whatever that is, and it needs to go live by whatever date, okay? And then I have this little table that includes the name of the product, delivery date, amount, whatever. So it's a very simple SOW that just says, like, my company's name, the name of the client, what products they purchased, the amount that they purchased them for, and the delivery dates. And so I have 4 of these, and they all look the same. They just differ in company names, and the target dates by which we're going to deliver certain products. Some of them have 1 product at a time, others have 2 products at a time. So I just played around with things in a very simple, calculated environment. So the first goal is, so these are PDFs that are all sitting on my Google Drive. And so the first task that I'll have then is going to be able to read the PDFs from this directory, and then turn it just into a bunch of actual Python strings. So because strings are going to be a lot more meaningful for us than having just the PDFs themselves. So I'm going to begin by importing a couple of packages, and I'm going to actually highlight 2 or a couple of these. So Langchain, which we, note to self, don't double click on things. All right, so Langchain is essentially a high-level wrapper for building LLM applications. We're going to be doing, honestly, some complex tasks in this demo, like reading text from PDFs, cleaning up that text, splitting text, which we'll get into in a second, creating a vector database, communicating with OpenAI endpoints, making sure that we're only passing relevant context to OpenAI endpoints. Langchain simplifies a lot of that process. So instead of having to low-level write all the code that does all of that, with Langchain, honestly, we can accomplish all of those difficult steps in like 6 to 10 lines of code. It's actually kind of ridiculous, and can make you dangerous pretty quick. ChromaDB is a open source vector store. I think I provide a link to their website later. And the other one that I'll call out here is OpenAI. That will be so that we can interface with the OpenAI endpoints. So the first step that we're going to do is we need to get these PDFs into memory. We need to grab all the texts that they contain. And so Langchain, like I said, tries to simplify every single step of the process of communicating or building these complex change and interfacing directly with OpenAI endpoints, any type of LLM endpoint. And so they literally offer dozens, and I am going to click on this. Oh, geez. So they literally offer dozens of different document loaders. So right out of the gate, if you want to grab information from YouTube or Google, or if you want to grab information from Azure Blob Storage, like they have high-level wrappers that simplify the process of grabbing all of that information. And one of those high-level wrappers wraps a Python package called PDF, where we will be able to just pass it the specific directory where I'm housing these SOWs, and it will automatically load them. So I'm going to import this class PyPDF directory loader, and then if I just pass it content my drive, test SOWs, PDFs, which is where all of these are living, I can see that the type for this loader object is it's just an instance of this PyPDF directory loader class. And it has this load method that when I call it, all it does is so really quickly, it read in all of those PDFs and then actually saves it as a list of Langchain documents. And now let's see what a Langchain document is. So if I go the first entry into this docs list, I can see, all right, it's a document. I see page content is an attribute, and look at this. So we see statement, new line, work with a random space. This statement of work is governed by blah, 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 blah. So it read in the text. I didn't have to do anything for that. I was just like, like I said, 1 or 2 lines of code. And here I've got the text from this SOW. There's a lot of new lines and random spaces in there, but we will tackle that problem in a second. But in addition to this page content attribute, we also have some metadata about this content. And one is it tells us that the source is this specific PDF called Beacon Hill Wellness SOW.pdf. And it's from page 0, which is just the first, 0th index. It's from the first page of that source. So super cool. Not only does it give us the content of the page, but it also preserves the file name, which could be incredibly helpful. We'll talk about that later, and the page number that it was on. So it's not just the text. And Langchain took care of all of that for us. So if we, let's see, so let's look at the second entry here. And then what I suppose is that it's also going to be from the same PDF, but it will be page 1. And I already did this, so I know this. So here you go. So if we look at this, if we look at Beacon Hill Wellness. So the first page has all the information. On the second page, it just has the word title. And sure enough, on the second page here, it just says that the content is the word title. And we can see that this is Beacon Hill Wellness SOW.pdf. And it's the second page indicated by page 1, even though that's confusing. So step 1 complete. We loaded in a bunch of data from documents, and it was really simple. Now, what I want to do next is revisit this text. It looks crazy. And what it looks like it happened, as we can see here, because if we return to the original PDF, so it has statement of work, the statement of work is governed by an agreement, blah, 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 blah. It looks like the spaces in the original PDF, instead of all those spaces, it has a new line delimiter. So I'm going to want to replace all of the new lines in this text object with a space. And occasionally we have random spaces. So even though on the PDF itself, there isn't any space in between, like after W in the word work, some reason came up in here. And we don't necessarily need to know why that is. That's something that we can easily clean up. So what I'm going to do is I'm going to actually copy this docs list, and I'm going to call it docs clean. And then I'm going to iterate over all of the entries in this list, and I'm going to replace all the spaces with absolutely no space, and then replace all the new line delimiters with spaces. And then we can see what the content looks like now. There we go. All right, so this looks a lot better. This is readable. Like we can read this, we can read all the text from this SOW as if it was right here, pretty much. I mean, some things that, we understand all of these visual elements like start date June 1st, end date July 31st. Like we know that these go together. However, in the actual text that it has here, it kind of looks like those are just part of some random sentence. So there's not necessarily the paragraphical call out. Another thing that I'll call out here is that in our SOW, we have this table here, right? Product name, delivery date, amount. We understand what this table is, but with this very generic PDF loader that we use, it doesn't seem to understand that because we can see, here we go. So we can see the titles for each of these columns, product name, delivery date, amount, and then it's just listing the entries for that table. So all I'm doing to call all of this out in specifics is don't be fooled by how easy it is to use Langchain to read PDF documents. Just because we can read it really quickly doesn't mean that this text as it stands will capture all of the information that we humans could glean from this PDF. And, just because we got all of this information from PDFs, like PDF still is not a great way to store information if you want to, I should say, out of the box, PDFs might not be the most useful. If we were able to have some type of structured database that had information about which clients had which products enabled and on when, like that would be a lot easier to connect to and then send to ChatGPT in a structured format. We don't have that here. So I'm just trying to illustrate, it's really easy to grab text from documents, but we probably will need to do, you can expect to need to do some additional post-processing work in order to make all of this text relevant to include in a context block to GPT. So I'm going to pause for questions really quick. And if not, if there are any questions, then I'll keep going. Okay. So now let's create our vector store. So we've looked at a directory full of PDFs. We grabbed the text from the PDFs. We cleaned it up a little bit. Langchain made that really easy. Now, in order to actually send this information over to ChatGPT, we'll want to create a vector store for a couple of reasons. And this is something that we talked a little bit earlier. Like, so one, if I had a question specifically about Beacon Hill Wellness Center, then it would make sense to send pretty much all of the context in this specific document to ChatGPT with the prompt, because this is all relevant. It's all about Beacon Hill Wellness Center. But then if I was going to ask a different question about a different client, then this piece of context would not be helpful. And maybe if I was asking a question that spanned really multiple SOWs or an entirety of them, I only have 4 here, but in a real life scenario, you might have relationships with hundreds or thousands of clients. So instead of just grabbing the data and then creating some type of data store with the text raw as it is now, we're going to do 2 things. One, we're going to split it up into reasonable sized chunks. And so what I mean by that is, let's imagine that if we had if we had 1 chunk per sentence in our PDF. So for example, the statement of work is governed all the way to and DocFinder Hub Pro company. Let's suppose that we made every single sentence in all of the SOWs that we comb into a chunk. That means that each sentence would get its own entry into our vector store. And so later on down the line, when we want to pull all of the relevant pieces of information, or the most relevant pieces of information to send ChatGPT, it would consider 1 sentence at a time which sentences or chunks are most relevant. And that is the context, you know, like the top 5 or top 10 sentences, that's the context that it would send to ChatGPT. Or if I decided, hey, I like this entire page as 1 chunk, then all of our text would be chunked at the kind of the page level. And then we would only have 4 different pages or data store entries that we could select from in order to send to ChatGPT. So again, this is a simple dummy example, but I mean, I know Chris has more experience with this, but I mean, let's say you're combing thousands of pages of PDF text and you want to be able to answer it all different types of questions, then you need to consider, all right, how much text should we include in a chunk? And then within those chunks, like maybe at the end of a specific sentence, we want to also include that end of that sentence at the beginning of the next chunk so that we can retain meaningful context. So Langchain offers a lot of text splitter high-level wrappers. The one I'm going to use here is very simple. It will just split the characters on these PDFs after a certain number of size, and I chose 1,000 characters here. And then I'm also going to apply a separator with a dot so that hopefully it'll say like, okay, sweet, I'm going to try to do about 1,000 characters per entry. And then if I see a period coming up soon, then I'm going to try to split at the end of that period so that we can retain a complete sentence. And with this chunk overlap equals 0 parameter, I'm specifying that I don't want there to be any overlap, like words that end the previous chunk, I don't want to be included in the next chunk. But the reason, so I chose this just because I have a simple use case, but in reality, if you are building one of these types of applications or chains on your own, there is a lot of room that necessitates playing with things here. So whether ultimately you get better results with much bigger chunks that have a lot of overlap or smaller chunks that have no overlap, that's definitely a parameter that needs tuned manually at this point so that you can get the best results in terms of servicing the right information to ChatGPT. Any questions on that? I know this is a very high level introduction. Okay, so what I'm going to do here is I'm going to split all of the text into chunks of size about 1,000. Okay, so now what I do, so now I have a list of documents that have been split according to these parameters. And so if I look at the first split, again, this is just essentially the first page of the first SOW that I provided. To show the difference here, let's say if I wanted to instead chunk by characters of about 100, It's going to give me a lot of warnings. It's like, hey, you said you wanted me to end at a period. I tried my best to do that. I came out with some chunks that are bigger than 100 characters, just letting you know. And so now if we look at what the output looks like, now my first entry that will go into this vector store is just the first sentence of that first SOW. And if I look at the second entry, all right, that's the second sentence. So again, the advantage to this, if we think that the types of questions we're going to ask ChatGPT, it will have the right amount of context with these smaller chunks, and we just need to select the right sentences to include, then that would be a route that would be more preferential to go down. But I'm not going to do that here. I'm going to keep it just one page at a time because I'm in control, and that fits well with the demo later. So, all right. So now we've retrieved the text from the PDFs, we cleaned it up, and now we just split it. The next thing that we have to do is embed our split documents. And I am not a pro at explaining what embedding is, but to me, it's the art of representing non-numeric data in very numerical ways that make those numerical representations really easy for AI models to understand. So what this really is doing is, instead of having just this big chunk of text, which really is meaningless to a computer, it means something to us, we're going to try to encapsulate the information in this chunk of text into instead an array of numbers. And now this array of numbers is not going to really mean anything to me, but let me describe, I'll describe something in a second. So again, with some of the other concepts that I talked about, Langchain makes embedding text very easy. And there are loads of different types of embedding strategies, endpoints, modules from which we can choose. I selected one of the embedding modules from Huggingface. And within it, we have to specify a couple of parameters, such as the embedding model, some different keywords. But if I run this, and then be patient for a second, okay? Then now what I have is an easy way that I can embed the content that I have from my PDFs. So again, here so to show you the difference between the actual text, and then if I embed it, it's just this massive array of numbers. And when I mean massive, like truly I scrolled up too much. It truly is massive. Like it's hundreds. It's hundreds of floating point decimals. So it's just a huge array of all this information. So I'm going to actually hide the output here. So it's just this huge array of floats. And so it's like, again, a huge array of floats, that doesn't mean anything to me. But again, what we're trying to achieve here is now we have this text that we can then embed. So we turn it into this numerical vector array. And the hope is that later, when we ask a question, or we have a question that we want to ask of our data, we also embed that. And hopefully that embedding will preserve similarities between the text that is relevant to us and the question, so that the model will be able to say, I have this question, its embedding came out like this. That's pretty similar to these other database entries. So I'm going to use those other database entries as the context to pass forward to ChatGPT. Any questions on that?
Yeah, I've got one. So if you chose to do the sentence embedding, how would the LLM know to pick? And you ask a question about this specific company, but about data that exists in another sentence. Would that work?
So I guess to make sure I understand your question correctly, you're saying like what happens if you ask a question and the vector store retrieval process doesn't surface the right content?
Or rather, the content exists in two different sentences or two entries in the vector database.
Correct.
Right? The name of the company is in one place, and then the data that you try to retrieve is in another place.
Perfect. I mean, so Chris, you know more about this than I do, but I would say that your overall, the entries that are in the vector store, you want to make sure that they have all of the relevant content that is needed in order to be able to respond to the questions. So for example, if I did chunk a sentence at a time, I actually, when I was playing around with that, got really horrible results out of the box, because if I ask a question, for example, about a specific client, the information of, hey, this is the client's SOW we're talking about, is only retained in the first sentence. So all of these other sentences, if I'm looking just at the content of the page, doesn't have that additional context that, oh, hey, all of this information is talking about Beacon Hill Wellness Center. So that definitely needs to be part of the chunking and overall data serving strategy when you're working through problems like this. That's why another good thing is, and so here I'm going to grab docs clean split again. So in addition to just the content that we have here, we do have the name of the file, which does make it clear to a degree that, oh, hey, we're talking about Beacon Hill Wellness right here. And there is a strategy that you can implement with Langchain, where when we're trying to retrieve the most relevant documents from our vector store, we can filter the results so that we can say, hey, I have this question for you. Filter the results so that the data pieces that we're pulling from only consider this specific PDF. If that makes sense.
Got it. That's perfect. That's what I was asking. Thanks.
I have a stupid question. Didn't quite follow. So let's say you have 4 documents, right? Document cleaned splits, you have 0, 1, 2, 3. So embedding each one separately?
Can you say your question again?
Yeah, see the example here, you're showing like docs cleaned _ split 0, right? That's only your first document. And then you do the embedding below. So you do them separately. What if those documents have same content? Like, say, half of the page is the same for all 4 documents. How is that?
Gotcha. So if I understand you correctly, you're saying, what if, like, let's say you're just combing through lots of information, and lots of the information within that text is very similar. It'll have, so then the idea is that the embedded, so that the embeddings for those documents would look very similar.
Okay.
And so there are strategies when you are sending when you're trying to select the right content to send to ChatGPT. Chris, you'll have to help me with the name here if you got it off the top of your head. But so it makes it so that instead of just saying, all right, so like, let's say you had a question and you put that question in there, it gives you 4 pieces of information, or 4 documents that essentially I'll say the same thing. That's maybe not as helpful as just grabbing one of those and then finding the next piece or the next document that maybe has some different information.
Okay.
There are strategies so that you can specify, like, hey, let's grab things that are definitely related, but if they're too similar to other document entries, let's only grab one of those, so that we can consider a more broad orthogonal types of information to actually pass to ChatGPT or whatever LLM endpoint you're using.
Okay, so you do want to embed each document first, and then to the second step, and then you decide how much you want to send it to ChatGPT.
Correct.
Okay.
Yes.
Thanks.
These are great questions.
Yeah, they're really good questions. And I have nothing to add. You're doing great.
Very kind of you. Okay, so the next step, now that we have all of our PDF data, and then we, so we at least briefly combed over the concept of embeddings. How do we create a vector store given these documents, and we want to embed that? This is so stupid easy, it's ridiculous. Okay, so Langchain, again, I mean, it just really is great at wrapping these high-level details for all of the complex process. Like, people got their PhDs on this type of stuff not too long ago, right? And here we are, and we can create a Chroma vector store, just specifying, here's the documents that I want in my database. Here's the embedding strategy that I want, which up here is where we said, hey, we just want to use this Huggingface embedding. And it's literally one line of code. Done. Takes a couple seconds. Granted, we're not using that much data. So it's doing some things on the back end. So there you go. So in 7 seconds, it combed over all the text from my split documents and then embedded it and then stored it into a vector store. Now, this vector store, again, is a Langchain object. And with it, I can say, all right, I can now, at this point, pose a question like, when did we sign the contract with Beacon Hill? And I can ask it that question. Now, with this, we're not asking a question to ChatGPT. Instead, what we're doing is the vector database is then just embedding this question that we're passing it. It's combing over its related documents, the embeddings in there. And here I'm specifying, hey, I want only one, the most relevant document in your database. I want you to grab that for me, and then I want to see what it is. So the hope is I can pose it this question, and it surfaces the document that applies to Beacon Hill. Let's see how it does. Okay. Document, page content. Let's go down here to metadata. Hey, it grabbed the Beacon Hill Wellness SOW. Excellent. How about if I ask it a different question, like which products did Vital Care, another one of the dummy companies, purchase? Let's get the relevant documents. Hey, it got Vital Care's SOW. So really simply, we didn't do any of the hard work. We now have a vector database that is up and running, and we can ask it specific questions and retrieve whatever number of documents. That's what we can specify with this K here, so that we get the supporting context that we will then pass to GPT. So then all that remains is to wrap this retriever in the prompt that we want to send to ChatGPT. And again, Langchain is going to make this super easy. Now, so all we have to do is a common path that I've seen for interfacing with OpenAI and notebooks like these is you have to have your own private API key, and then you'll save it as an environmental variable on your own, laptop or whatever you're using, whatever, cloud environment. I'm just using Google Collaboratory here, so I have this blanked out. But then all we have to do is this. So with Langchain, it makes it easier to interface with ChatGPT. So we're going to interface with the OpenAI endpoint. And all I have to do is instantiate this chat OpenAI class. And I'll specify, hey, I want to hit the GPT 3.5 turbo endpoint. I want the temperature to be 0. We're not looking for creative responses from ChatGPT here. And verbosity to true. I actually played around with this. This might be a Langchain bug because it doesn't really seem to do anything. So I'm just specifying, essentially, this is the endpoint that I want to use in order to ask my question. And then Retrieval QA is a Langchain class that is specifically designed for question and answering retrieval augmented generation type frameworks. So for this Retrieval QA class, I can instantiate it by saying, hey, I want to create this Retrieval QA chain. My LLM is what I just specified up here. So it's the GPT 3.5 turbo. The retriever that I want to use, we actually just instantiated up here where we said, hey, retriever, this is our object that is specifying we want to retrieve messages from this vector database with a search K of 1. So this is only going to retrieve the topmost result to pass as context to ChatGPT. And then I'm also going to specify this parameter here that I want it to additionally retain the source documents that it's passing so that we can play around with that and see what's going on behind the scenes here, okay? So I'm going to run this. And actually, before I pass it, I want to show something. So for this QA chain model, so there is a method that we can call that's called dict. And what that does is it outputs a dictionary representation of kind of what's going on behind the scenes for the LLM chain. And in that here, we can see there's a lot of information here, but I want to highlight is it gives us details on the prompt that it is actually crafting with this information that we've provided. So check this out. So there's a prompt template here that says, use the following pieces of context to answer the user's question. If you don't know the answer, just say that you don't know. Don't try to make up an answer. New line, context. So it has, so that's the input variable is the context, and then it passes that prompt again to another prompt, which is just waiting for a question. So essentially all this is doing behind the scenes for us is it's providing a really quick way to essentially craft this prompt that says, hey, use this context to answer the question. Here's the context, which will be the output from our vector store. And here is the question that we're asking. Okay, so that's what Langchain is doing for us behind the scenes. I'm going to go ahead and delete this. So let's ask it a question. And let's see how it does. So the first question I'm going to ask it is, on what date did we sign with Beacon Hill? The date of signing with Beacon Hill is May 16th, 2023. And I'm going to go ahead here and look at Beacon Hill, May 16th, 2023. We did it, folks, like mic drop. Our work here is done. No, I'm just kidding. Bad joke. So that's awesome, though. Like we were able to accomplish this thing. And what we can do is we can look at this actual result object. So all I'm doing is I'm grabbing the result attribute from this result object. If I look at what else it contains here, it has the query that I originally sent it. It has the result from ChatGPT, or sorry, the GPT 3.5 Turbo endpoint. And then here is the source documents, because remember, we asked it to retain this for our inspection later. And so here is the source document that it retained so that we can go and say, all right, cool, we got the right answer. We know why it makes sense. This is the context that we provided to the GPT endpoint. Okay, let me ask it another question, and then I'm almost at the end of the demo, and then I'm going to show why my chunking strategy was not good for certain use cases. So additionally, let's say, which products did Beacon Hill purchase? One thing I want to call out in the SOW is it doesn't actually say the word product, but you could derive that context by the company will onboard the client onto MetaMatch Pro and Metabot Pro. So you could assume that those are the products. Oh, actually, no, I lied. Look at this. It does have product name in the table. But the table didn't come through great. So let's see how it does with this question, though. Beacon Hill Wellness Center purchased 2 products, MetaMatch Pro and Metabot Pro. Sweet. So it was able to answer a couple of questions about Beacon Hill. Let's ask it a more generic question about, out of all of these SOWs, which clients purchased MetaMatch Pro? One of the 2 products. Let's see what it responds. The provided context does not mention any clients purchasing MetaMatch Pro. Therefore, it is not possible to determine which clients purchase it based on the given information. Why didn't it know? Let's see what's going on here. So let's look at the source documents. And so we can see actually that after embedding this question, passing it to our Chroma vector store, it thought that the most relevant piece of document, because remember, way long ago, we specified that we only wanted to grab the most relevant document instead of documents to pass over to the GPT endpoint. And it decided that Sunrise Medical, for whatever reason, was the document that it was going to pull. And I asked a question about MetaMatch Pro, and if we go to Sunrise Medical's, wherever it is, they didn't buy MetaMatch Pro. They only bought Metabot Pro. And so it didn't have any types of information in the context to actually answer the question, so it didn't bother. It just said, sorry, I don't know the answer to this question. So what this really highlights is that for specific questions about Beacon Hill, only like chunking all of our data as 1 page per chunk made sense. And then surfacing only that most relevant page to ChatGPT as the context made sense. But for other types of questions, like which clients purchased MetaMatch Pro, we obviously need more context because pulling them only the most relevant in the embedding space document wasn't the right context, and it was insufficient to be able to answer this question. So instead, I can go back and I can say, all right, instead of just grabbing the top document, let's just throw all of the documents. We have 8 pages of PDFs here. I'm going to go ahead and instead allow ChatGPT to have all of the potential context that I can provide. And I'm going to ask it the question, which clients purchase MetaMatch Pro? And let's see, it says the clients that purchase MetaMatch Pro are Tranquil Grove Hospital and Beacon Hill Wellness Center. So I can see here, so this is Sunrise Medical Group, doesn't have MetaMatch Pro. Tranquil Grove Hospital does. Vital Care Regional Medical Center also does, but they weren't included in that list. Beacon Hill Wellness Center did purchase that product. So here, ChatGPT is 2 for 3. And even though we provided it all the context that it could potentially need. So then the question becomes, all right, and then, we can look at the source documents here. So this is just showing, all right, we threw everything that we potentially had at ChatGPT. Why on earth might it not have known this? Well, then we're getting into the discussion of, maybe we should have done a smaller chunk size and made sure that we could only pull out the specific sentences that were dealing with the products that were provided, because all this other stuff about the price and, statement of work is governed by an agreement, all capitalized terms not defined, blah, 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 blah. All that information might not be helpful to include in this prompt to ChatGPT. So that's where we need to modify how we're chunking the data, how we're splitting it out, how we're making sure that the right context is preserved in each of those chunks in order to be able to create a vector store that ultimately is much more helpful for a more general set of questions. And so I guess in order to conclude this demo, man, that's a lot of nonsense. The two things that I'll highlight is that, and hopefully we got to showcase it here, is that even though the technology and the high-level wrapper that Langchain provides in order to be able to accomplish this entire sequence of different steps does definitely simplify our lives if we're building applications like these, but still it all comes back to the data and getting the data in a format that will make it easy to ask a whole general set of questions. That is an art form. There's definitely no, like steps 1, 2, and 3 that you can follow for all the many different types of data question and answering use cases that are out there. In addition, actually, I lost the second thing I was going to say. My train of thought has exited me. Oh, yes. And so in addition, let's say we had stopped after this first successful thing, okay? Which products did Beacon Hill purchase? We got the right answer. I get excited. I go to my boss and I say, I solved all of our internal question problems. Give me 2 weeks. I'm going to build this app. I go and I build the app, and then I go and then I showcase it and I say, hey, check it out. You can ask this question and get the right answer. And it goes, cool. And then all of a sudden, other people start asking a bunch of other questions. Well, that's where testing really plays a significant role if you're building applications like these. So instead of, it's really important to have test questions for retrieval augmented generation applications, so that not only are we, just doing some preliminary testing to make sure that all of the pipes are working as anticipated, but really we have to have a range of questions that will represent all of the different flavors of questions in different forms that we might expect this chatbot to ultimately be able to speak to. And against those broad test questions, that is what we're going to want to fine tune our vector database, our chunking strategy, how many chunks to include in the context at which time, all of those different types of things. So there is a lot to consider, even though Langchain is helping us make the pipes a lot easier. So I covered a ton there. What additional questions do we have? And I know that Chris has been manning the chat voraciously.
Yeah, it's been lively. Okay, so one thing that I just want to circle back on that there seems to be some confusion about that I see with how the documents are retrieved from the vector database. So I just want to dig in really quick on embeddings and what we're actually doing when we talk about embeddings and searching and all of this stuff. Okay, so we take all the text and potentially this is a point of confusion because of how simple we made this demo, right? But essentially you take a bit of text and you embed it, right? So this embedding model is actually trained to keep, so when we say embedding, all an embedding is think of a line in the easiest way to think of it is as a line in two-dimensional space. So think, you know, mx plus b, right? So it has a slope and it has a direction. Well, technically it doesn't have a direction, but they're vectors, right? So they have direction, a magnitude, which is the length. But anyway, think of a line in space, right? If I have a line that represents dog, and I have a line that, and these are fixed length, by the way. So you can embed a single word, or you can embed an entire page of text, and it will always be the same length for the embedding, right? So we think of these lines and we say, okay, in space, right? What is the distance between these lines? Well, dog and wolf are going to be around the same distance in that space as the line of cat and cougar, right? But cat and dog are probably going to be more similar than cougar and dog, right? And vice versa, cat and wolf. And so because they're pets, right? So when we train an embedding model, what the embedding model is actually trying to learn is not only how to embed various words, but also the relationships between various words and various pieces of text, so that when it sees something new, it has the ability to place it in the correct place in our space, near things that are related to it. So that's what we're doing here is when we embed the text from these documents, what we're doing is we're saying it's learned how to place these or create these embeddings such that you're putting things together that are related, right? There's some crazy relationship that our brains don't really understand, right? Because of how large these vectors are. They're in n-dimensional space, not two dimensions. I was just saying that to be able to think about it. But like what ends up happening is the idea is the same, right? So that when we have all of these vectors from one place that are related, right? All of these lines that are related, they're not really lines, but we'll say they're lines. When we get this query from a user and we create a fixed length embedding for that, right? When we go to look up vectors in the database, we're looking for things that are as closely related as possible, meaning the distance in that space, right, is as close as possible to the query the user is asking. What that actually means is that text is like really related in a way to the query.
No,
right.
I think that point is understood, but what is happening under the hood, maybe I'm misunderstanding, is the question that you ask, the prompt that you ask, goes and queries the vector database, gets the closest embedding from the vector database, retrieves the actual text of that embedding, and puts it into the LLM prompt.
Correct.
Right?
Correct.
Right. So if you are looking at, to distill information from, in this case, 4 documents, it needs to read all of those 4 documents, to send all of those 4 documents to the LLM prompt.
No. It does not need to do that. It pulls whatever was relevant from the vector database and feeds that to the LLM prompt. So whatever it found to be relevant, it only pulls that thing. It doesn't need to pull all 4.
I mean, in the case where we have k equals 8.
Oh, yes. Yeah, right. If k equals the number of embeddings you have, then it will always pull all of them, right?
All right, cool.
Yeah,
great.
Yeah.
So in a case where we need the LLM to distill information from documents, this is probably not a scalable approach. We need to think about it. Okay.
Yeah, exactly. That's the whole point that he was making at the end, was like, this jumping strategy sucks. Right? Yeah, totally.
So,
okay, I see that.
So by you saying something being similar, that's based on the probability, right? Is there a way, like who is decide like what like how do you decide which one is similar than the other one? That's
great.
Decide by the model.
It's a great
itself?
question. No, it's not. It's not actually by the model. So the model is fixed, right? It's not outputting probabilities. It's outputting vectors, the vectors themselves.
Right.
The similarity metric we're using for all of those who have taken vector algebra, vector calculus, those types of things. We're looking at usually like, well, so this is where it gets nuanced, and I'm glad actually that you brought this up. So the embedding model uses some distance metric, whether that's Euclidean distance. Cosine is a very popular one, which measures the angle between the vectors, and then also the dot product, which also takes into account the magnitude, right, or normalizes the magnitude of the vectors. But nevertheless, one of these distance metrics is actually used to train the model. And in order to get vectors that are similar, when you embed your query, you use the same distance metric that was used to train the model. And you can think about why it wouldn't make sense to use a different distance metric, because you probably wouldn't get good results if the model was trained using cosine and you use, say, Euclidean distance, which is somewhat like the direct as the crow flies from one to the other.
I should have said distance. I don't know why I said probability. But then,
yeah, that's fine.
So now you just, let's say you enter your query, and then you just compare, like you want to top the one have the shortest distance, pretty much.
Yeah.
Okay.
And you can play with that. You can play with that metric too. So again, this is a different way of thinking, but sort of you can think of a lot of these knobs that you can turn as hyperparameters, right? So your similarity metric and the threshold that it must clear to be considered similar is actually adjustable. So it's at 0.8, I think, by default when you're using, say, cosine. But if you can raise or lower that to either capture more or less, right? And so that is also something you'd want to play with during testing.
So where was that set? That's what I didn't catch.
That
like
gets set. No, it gets set on when you make the during the search. So you can say, give me all the documents, the top K documents where the threshold is greater than a certain threshold. Yeah.
Cool. Thank you.
And you can specify, as Chris mentioned, basically what it's using to determine what is closest. And so on the Langchain documentation, they talk about, hey, are we using similarity MMR or similarity score threshold? And there's some documentation for these different strategies that are there.
Yeah, actually, I should take a step back and say that also that similarity. So there's something called dang it, it's called nearest neighbors, approximate nearest neighbors. So it actually will use to figure out like where things live in space. Things will often cluster together, like that are similar in n-dimensional space. And so you can use so you may have heard of K nearest neighbors. Approximate nearest neighbors is actually a faster, slightly less accurate K nearest neighbors that allows us to also to search out and find these vectors in n-dimensional space, right? So that's actually a common way that they're doing it. And I should have mentioned that. I was saying cosine and all this stuff, but approximate nearest neighbors is a similarity metric that's used to seek out vectors that are similar to what you're looking at. And I believe that's what MMR is, but I forget because there's so much dang information out there. Right.
Other questions? Good discussion.
I have a question. So in terms of just like chunking the data, would you suggest like running the chunks through GPT and then or creating some kind of like a script or a function that can, with some prompt engineering, that can summarize the relevant data that you want in each chunk and then vectorize that so that each vector has more relevant information? Is that an approach you would use, or?
it's all of these things, and that's a great thing to think about, because honestly, you're trying to reduce the amount of text that you're trying to bring back to feed context to these models. That's like the name of the game, is token reduction while maintaining context. So that's one way to do it. I wouldn't say I don't recommend it, but it's going to be an annoying answer in that it depends. Right? It depends on your data and like what you're trying to achieve and kind of the results that you're getting. So just like with machine learning, there's models, there's techniques, but for any given problem, any combination of those techniques could be the right way to go. But it really comes down to kind of an art form and playing and knowing your data as to what technique you use.
Let's see. So maybe just as a follow-up, so maybe like verbose data, that's maybe a strategy to use, because there's lots of like filler words and things that aren't very important for like the core meaning of that text. Whereas maybe if you're trying to, like, would this work with like Excel files or like really large sets of tabular data that you want to like save for the bot to analyze later? Or?
That's a really good question. So when you're starting to talk about structured data, we're talking about something different, right? Like the techniques that we're looking at here are for unstructured data, right? But once we start to get into tabular format or some sort of structured data, it actually starts to become a different problem. And you start to think about agents, and you start to think about models that can produce queries, right, to get at that data or look at that data. So, and there are different ways to get that in, but like with structured data, you can think about how it wouldn't make sense to like take structured data and make it unstructured, right? You want to get at that data as structured data because you can just write a query and get what you want, right? And so there's different ways, and I mentioned a couple there, but different ways to get at that. One thing that's very popular right now that's being worked on furiously, and I'm working on a project on it right now, is the concept called agents. So agents are things that actually make a decision on how to get the data that it needs based on a description of tools that you provided. Those tools could be something like a database, right? Access to a database. It could be web search. It could be this unstructured vector database that we're talking about. Each one of those tools then has a free-form text description of what that tool should be used for. And when you actually use the agent, what the agent does is when it gets the user's query, what it does is it first goes to OpenAI or whatever your model is, right? A GPT or otherwise, but it goes to that model and it says, hey, model, we have this user query. Based on this user query, and based on the tools you have, the descriptions provided for those tools, choose a tool that you think would be good to answer this question. So it uses something called chain of thought to understand how to get it access to that data. So if you have something in tabular format, potentially the model would say, well, I know I have that data, it has some sort of table schema. You can provide table schema. You can do all sorts of crazy stuff, but it might choose to use that Excel spreadsheet, and that tool to get at that Excel spreadsheet may just be something that loads it into pandas, and the thing accesses that automatically, right? And you need to write the functionality on what it looks like to access and use that tool. But essentially, you can provide it these tools to let it make decisions for itself rather than you having to give if-else statements for every single possible combination of things that could come in from users. And that was kind of a tangent, but there are, yes, you don't have to use a vector database. This is a way to get at unstructured data. You could also just like do this yourself and load the structured data, which we're kind of doing here or the unstructured data into a structured format. Here it's a vector database. Perhaps there's other ways you could do that.
So I dropped the question in the chat. I haven't answered, which I'm not clear. It's about this vector database, right? So is it true that this is only generated for the particular session you're working on, right?
Yeah, in this case it is. Yeah, it's loaded in memory.
Okay, so what do you want to, in a production environment, you want to reuse this kind of stuff?
Well, yeah.
If you want reuse, then you would host this on a separate server, right?
But
Or they have.
How do you store it? Like,
so one thing I will add is, so
Yeah.
I mean, just right within Langchain, there is the opportunity to specify an attribute called persist directory, and then that will actually allow you to be able to store it on disk. But as Chris talked about earlier, so Pinecone is a managed vector store, so that you can actually store that in the cloud and have somebody else manage all of that. And I'm sure that there's lots of other companies that are popping up and have already popped up that are offering similar functionality for a cloud-based solution. But yes, it doesn't have to just be something that stays within memory and dies when the notebook gets turned off.
Okay. Yep. I forgot a Pinecone you guys were talking about earlier. I forgot.
No,
Thanks.
yes.
Well, you guys did a great job. Thank you.
Thank you. Yeah, and just to be clear, that's, there's Redis, there's Azure just came out with a vector store. Any key value store really that you can think of is probably able to be used as a vector store, because a key, remember, is nothing but an array of numbers, and the value is nothing but strings. So as long as the keys are allowed to be a vector of numbers and the values allowed strings, which I cannot think of a database that wouldn't allow that, but maybe it's out there, then you're good. It could be used as a vector database. I mean, it could just be PostgreSQL, right?
Cool. Well, thank you guys so much. This is great.
Yeah. I think we got
all the questions. Were there any more questions, guys, or guys and girls and all?
We're good.
One, what would have happened if you asked to give the delivery date?
Brian, do you want to type that in? What would happen if you asked to give the delivery date?
Yeah.
For which one? Just in general, or
any delivery date? Like, pick a company.
Okay. So I'm going to scroll all the way down here. So I'm going to go back and I'm going to pick a single company so that I can keep the context a little smaller. Okay. So I'll say, when did we tell Vital Care we'd deliver, we would deliver MetaMask Pro. Let's see what it says. There is no mention of Vital Care in the provided context. Oh, so it grabbed Tranquil Grove. Interesting. It grabbed it once it understood that we were, once it grabbed just the top context, by March 31st.
It's impressive that it could understand that. Cool.
I know, right? Despite all these limitations, I guess that's the kind of the TLDR right now. Is that's why there's so much hype about this, and like so much excitement. I don't want to use hype too negatively. That's why there's so much excitement, because I didn't train any of this model on my own, right? Like, that's in the past, that's what you would have to do. All I'm doing is just passing in a couple pieces of information, and it can take care of lots of the really hard part on its own. And all we have to do is just be curious and ask it the questions and structure the data on the back end. Granted, hopefully we also communicated that even for a simple use case like this, that's easier said than done. And so if you're in the data field, like, your job's not going away just because an LLM can answer questions like this. There's still so much work that has to be done on the back end. But it is a really powerful tool that we definitely should explore. So it's not all just hype.
Agreed.
Cool. Thank you.
Yeah, good question. So I guess to kind of wrap this up, I'll make this demo available and I'll post that in the in the group chat, or sorry, the Slack channels that we have for the Python Pirates. If you're not already on there, definitely join. It's at no extra cost to you. But Chris, any parting words?
Oh my goodness. Just get really curious with this stuff. The only way to really know it and learn it and discover the nuances is to actually play with it. And the more you play with it, the more you realize how
not straightforward this is.
As simple as it looks, and it actually it raises very interesting questions. There's a really active space, which is always very exciting to be in, and I've always kind of lived in that space during my career. So if this fascinates you, this technology is crazy on fire right now in industry. So if you do learn this stuff, like really learn it, you will become very popular. Okay, so that's why I was mentioning the courses and the deep dives earlier. If you do this stuff, this is being asked for everywhere. Not just like, hey, we need prompt engineers, but people who really deeply understand how all of this fits together. Because what companies are really trying to do right now is build scalable solutions. So if you can combine this with some sort of cloud credential or just cloud knowledge, right now it's just so in demand, and there's so few people who know it that you will be sitting very pretty in the job market. So just FYI from what I've seen. But other than that, really good questions, really good discussion, and Brian, great demo. That was really awesome to see all the nuances, even in such a simple example. So thanks for that.
Hey, thanks for asking. Yeah, thanks for asking the great questions and for sticking around to see it. It's been fun to learn.
Yeah, the video will be available as soon as possible within the week on our YouTube channel. And then the slide deck and the notebook will be available in our Slack channel, as well as the description of the video. So look for it there. And other than that, everybody have a good night, and we'll see you next time.
Hey, thanks so much.
Thanks.
Thanks, everybody.
Thank you.